It is now my pleasure to introduce the next speaker, which is Florian. Florian is a postdoctoral research fellow at the Immunity Transplant Infection at Stanford University. Florian, the stage is yours.
Much. Good morning, everyone. It's such a great pleasure to talk today at the GAIN Science Slam from the comfort of my own living room. As Aline mentioned, my name is Florian. I'm a third-year postdoc at Stanford University, where I use biological and computational tools to investigate the immune system. For the first part of my talk, I actually prepared a big speech. I was going to explain how the immune system is my absolute favorite part of the body, how it's this fascinating and complex network of cells and molecules that work together to protect us from disease, how it is involved in virtually every process in our body, including aging, cancer, the neurological diseases, and of course, the defense against infections. And I was going to say that because of all this, understanding the immune system better will help us fight many different diseases. And in these special COVID-19 times, we immunologists don't really need to work hard to explain why one should study the immune system. So let's rewind to February 2020. When COVID-19 cases were starting to spike, my colleagues and I dropped everything we were doing and embarked on a race against sleep to understand this new disease. Here you can see my colleague Prabhu and I in full gear during one of the experiments. I'm not sure whether you noticed, but at that time we actually still had professional haircuts. Today I'm showing off the new COVID haircut done by a reluctant volunteer family member. All jokes aside, this pandemic is a serious global crisis, and up to now, SARS-CoV-2, the virus that causes COVID-19, infected more than 22 million and killed more than 700,000 people. While the disease is mild for the majority of people, about 15% develop severe symptoms that require hospitalization. A minority of these develop acute respiratory disease and are admitted to the intensive care unit or ICU. In extreme cases, COVID-19 can lead to death, and the fatality rate is actually several times greater than with the seasonal flu. While research has moved rapidly in testing candidate vaccines, we actually don't know a lot about the immune response to COVID-19. An important question in this context is how the immune system fails to protect patients with severe disease. Early on, researchers observed excessive immune activation called inflammation in some of these patients and proposed that inflammatory molecules could contribute to severity. So today, I'm going to take you with me on our journey to get a better understanding of the immune response to COVID-19, and I'll tell you what might go wrong in severe cases. To gain deep immunological insights in a rapid fashion, we used a new approach called systems biology. In the past, researchers looked at the immune system by studying single pieces in isolation. Systems biology combines the power of biology and technology to take a look at the big picture and to study how all the pieces work together. This approach enabled us to measure a large number of immune cells and molecules in parallel and to determine how the immune cell network collaborates to fight COVID-19. Using systems biology, we analyzed blood samples from 76 COVID-19 patients and compared them with samples from 69 healthy controls. Now, first we set out to check for these inflammatory molecules that initial reports linked to severe COVID-19. One of them is called IL-6, and this plot shows you the IL-6 levels in patient blood. What you need to focus on here are the purple dots, which are the moderate cases, and compare them with orange and blue, which are severe and ICU. Severe and ICU are clearly higher, which confirms the initial suspicion of inflammation and severe disease. But that's not the cool part. Using systems biology, we actually measured the levels of 90 additional immune molecules in the same blood samples, shown here. Of all these measurements, we identified 3 novel inflammatory molecules with high levels in severe patients. These are all involved in lung inflammation, but were previously not linked to COVID-19. We did many additional analyses, including multiple single-cell approaches to get the big picture. And we found that during moderate disease, patients produce antiviral molecules. In severe cases, we found that despite the inflammation, especially in the lung, the immune cells in blood are actually suppressed and unable to respond. We even found bacterial products which correlated with the levels of inflammatory molecules. Together, this suggests that patients with severe disease are stuck with an immune response that doesn't seem optimal to fight COVID-19. At the moment, we are testing whether we can block the new molecules that we identified with the hope to improve the immune response early on. Systems biology has been fundamental for us to gain a comprehensive overview in short time. For all the immunology geeks, I've put a link to our paper in Science here at the bottom. This project was a tremendous team effort spanning multiple continents, and I want to highlight all the brilliant people that contributed, especially Prabhu and Bali. Thanks for your attention.